Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Know-How is brought to you by CacheFly at CacheFly.com.
This episode of Know-How is brought to you by iFixit. You can fix it, and iFixit makes it easy with free step-by-step repair guides, high-quality replacement parts, and all the tools you'll ever need. For $10 off your purchase of $50 or more, go to ifixit.com/twit and enter the code KNOWHOW at checkout.
Today on Know-How, we'll be breathing new life into old electronics.
We're going to be doing something with this mysterious blob of stuff.
And finding the best motor for your quad.
Welcome to Know-How. It's the Twitch show where we build, bend, break, and upgrade. I'm Father Robert Baldassare.
And I'm Brian Burnett.
And this under the sheet here, it's who knows? It's probably a quadcopter, Brian.
This is definitely something that has to do with quadcopters, right?
That's all we do on this show.
Well, it's clearly probably like some sort of mobile platform for DJI.
A boxy quad. But you know what? We're going to ignore that for now because we've got something more pressing to talk about.
Very easily ignored right here.
Just pay no attention to the thing behind the curtain.
Nothing to see here.
Yeah. Brian, we're kind of in a drought, huh?
Yes, California has been suffering for the last few years.
Yeah, years. And you know, it's funny because we've been having droughts on and off since I was a kid.
Yeah, this one seems to be sticking though.
This is sticky, and it's kind of scary because like you drive, the 152, it drives past this huge reservoir on your way over to the 5. And when I was a kid, there were years where the water would come up over the roadway and it would shut that thing down. That's how high the water is. I can now barely see the water. It is so far receded and so many hundreds of feet down that it goes nowhere near the roadway.
Yeah, that's really scary. And it's not just drinking water that is affected. It's the recreational stuff that you would like to do, like going to Tahoe and enjoying the snow, which the snow is kind of where we get a lot of the water over the summer.
That's the other part of it, which is we depend on the snowpack. No snowpack means we don't get water throughout most of the year.
Exactly.
And the snowpack doesn't really exist anymore. The snowpack's kind of gone, but skiing and resorts is still a multi-million-dollar industry in California, so we thought we might want to talk about the technology that goes into making snow. We've all seen snowmakers, but the more advanced ones are actually far more complicated than you might think they are.
Yeah, I guess I just always imagined you get a refrigerator, you shave some ice, and you just shoot it out and just...
Right. That's what most people think
and do it consistently so it doesn't all melt at the same time.
Snow is just shaved ice and you throw it. Well, but we know that that's not
more
true.
Than that. Yeah.
Because real snow, you get powder, right?
Yes, it is much nicer to ski or snowboard in powder than like ice. Hard pack ice. That's when you get hurt.
Anyone who has skied knows that skiing on ice it's not fun. It's hard on your feet. It jitters. You just don't have that much control. It's too fast sometimes, too slow other times.
It's scary.
It's scary. So you actually do need snow, and because it's more than just chopping up ice or more than just spraying water in the air and hoping it freezes, well, wow. Alex is making it snow.
Make it snow.
That's not...
Make it snow.
Don't hold me back anymore. We just got copyright infringement.
Despite the best efforts by Disney, it still has the... There goes the little cloud.
Bye. Specifically, I want to talk about this multi-step process that some of the bigger resorts are using with multi-million-dollar pieces of machinery.
This is their industry. They got to figure out a way around this.
This is their industry. So the first part has to do with spraying water. But it's not just like opening the tap. You don't just turn on the sprinkler and
right.
You divide your water into multiple planes. So you might have one plane going this way, one plane going this way, one plane going across. The idea is to have the planes intersect with each other, because when the planes intersect as the water is spraying out, it breaks them up into tiny little droplets.
Right.
And the more droplets you have, the more surface area you have, which means the faster that they'll freeze. Because remember, you need these things to turn into snow before they hit the ground. Otherwise, it's
you're
ice.
just watering. Yeah, you're icing the ground.
A huge icicle.
And
but that's not it. That will give you part of the solution. The other solution is something that we figured out when we were trying to make rain. Have you ever heard of like seeding clouds?
Yeah.
They use a process called nucleation, which is you need something that either the water droplet or the snowflake will form around. If you give it something, it will actually glom and then it will form. It's like, have you ever done the quick freezing beer?
Oh, where you put it in the freezer for a little while and then...
Yeah, and then you'd like tap it and suddenly... Right, that's supernucleation. All the liquid is really, really cold. It's cold enough to freeze, but it doesn't have anything to form around, so it doesn't. When you tap it, you disturb it enough that you get like little bubbles. The bubbles become nucleus, and then it just spreads.
And that's what they can glob. Is that the scientific term? Glob onto?
Totally glob. Totally glob onto it.
Glob it up.
So now you've got the spray breaking up the planes. You've got the nucleation so that they have something to form around. There we go. See, this is what it looks like. And this actually shows you the last step, which is pressurization and compression. Have you ever used a bottle of compressed air?
Yes.
And you know that when you spray it, it gets cold, right? The bottle starts to get... Well, that's a law of thermodynamics. You're decreasing the pressure, so therefore the heat is exothermically escaping.
Okay.
Right? Well, what you do is you shoot high pressure air into these things, and because there's such a pressure difference, it actually drops the temperature. So these things can work. I believe the most advanced one can work up to 10 degrees above the freezing point of water.
Wow.
Yeah.
Okay.
So I mean, when you think about it, it really is a science, and it's really different now than it was, again, when I was a kid. When I was a kid, those snow machines really made ice.
Yeah.
But now you got an advanced snow machine. It feels like snow.
Yeah,
really
that looked like powder. That little mound that they had built up, that looked like it had just snowed overnight or something like that.
Yeah.
Cool.
So yes, we may be in drought, but we'll still ski because
for as long as we can.
Technology.
Yeah, if only we had technology to make more water too. Or do we?
Maybe that's what's under this curtain here, Brian.
Oh, is this our magic? It's a snow cone maker?
But wait, Brian. Magic reveal. It's a quadcopter, right? No?
Wait
for it. Boom. That's right, folks. We're getting into 3D printing. This is not a quadcopter. It's not a It's not a panini machine.
Rotisserie?
Not a rotisserie. We promised you that we would start to get into 3D printing, and this is actually a brand new printer. This was just released yesterday. We got this a month in advance from the folks at XYZ. We first took a look at this at CES. We brought it back in our CES coverage. This is the DaVinci Junior.
DaVinci Junior. And what isn't the appeal that this isn't that expensive compared to other
$349.
$349.
Yeah. So, and we're actually going to have the full review of this tomorrow on Before You Buy. So make sure you watch Before You Buy. You get to see the whole rundown.
I wants to play with it.
And keep Burke away from this too. Now, the whole idea is they had a very successful product called the DaVinci, the 1.0, which was nice, but it was a little expensive. I mean, even now it's still $500, and back then you could get it for like $600, $700, $800.
Okay.
Which was affordable for a 3D printer, but still... It's
still out of the range of your average day, hobbyist.
I mean, if you're just looking to play with 3D printing, you're probably not going to pay $500, $600, $800 for it.
That's a pretty big investment for that.
$349, not bad, actually.
Tempting.
Tempting. And the nice thing about this is the way that they've built in the features. Again, we're going to go over this and Before You Buy in depth, but things like the removable head. One button, I can take the head off. That's been one of the biggest problems with 3D printers because they jam, and then you have to disassemble the entire machine to get at it. This, I push one button, I lift this up, I literally bring the head over here, and I push a button, and I can slide this whole thing out.
I like that. It's kind of modular.
Yeah. It also does PLA only. Now, there's two types of plastics that we use. It's called filament. So when we talk about filament, we're talking about these spools of what looks like, plastic. This is just plastic that's been rolled up. This is PLA, which is actually, it's an organic product. It's like polylyseric acid.
Yeah. But so there's this one, and then the other one's ABS,
right.
Which is...
Now, ABS is a bit stronger because it's actually more flexible. PLA will tend to fracture before it really starts to bend. But PLA is an excellent material to start with. So again, this is a starter printer. This is what you would just kick off your 3D printing career with.
Right. And you have a few examples here that you've built.
Yeah, I mean, look at these.
This is a little structure that you made for the quadcopter, and this feels really solid. And then this is like a fairly complex little shape that you built, and it's not very thick, and you can kind of squeeze it and stuff, but it feels solid.
It feels solid. And then you've got everything from, like, these are, this is the rear mount for a tricopter. And I don't even have this set at maximum resolution. So the maximum resolution for this is 0.1 millimeters. That's the small, the height of the layer that it can lay down. 0.1 is actually pretty good. This will go all the way to 0.5 if you really don't need that much definition. But the cool thing about a printer like this is you can manufacture these parts, which then bolt together, and you can do all this and change it within hours rather than days. And your design can really be fast prototyped.
That's super cool.
Yeah. One of the other things I like about this is this bed. This is a non-heated bed. If you go to the front shot, Alex, right here. So the way that this works is this head just goes back and forth, up and down. This kind of motion, that's actually handled by the bed.
Okay.
Forward and back, right? So I get all degrees of motion, but I don't have to worry about a multi-dimensional arm up top.
Right.
This is actually a really good combination. Now, one of the other features I really like about this, it's a standout, I think, is this ability to put your designs on a card. So this is just a standard SD card.
Yeah.
And I load it up, and now I can select from the front here, I can build from card. I can select a design that I want to build, and it does it completely isolated from a computer.
That's cool. Yeah. That's really easy to use then.
Which is good for a workshop because you don't want to have your computer hooked up to the 3D printer for 3-4 hours, however long it takes to complete your print.
That seems very well thought out.
Yeah. It will print up to 5.9 by 5.9 by 5.9. So you get a cube of what you can build in here. But what you'll find in a lot of designs is you can break up the designs into the pieces that then get bolted together.
The smaller components.
Smaller components. Now, like this is one that I actually created because I started off with this. This I downloaded from the internet. This was an FPV pod for a Fat Shark camera. So it actually has slots here, so the Fat Shark camera will fit into the front, and then the battery will fit in here, and you put the little transmitter. And so now you have an FPV pod that it's like a self-contained transmitter if you want to fly first-person view.
Very
you
cool.
Just stick it onto your quadcopter, you're good to go. But I wanted something that didn't quite do what I wanted to do, so I took that design and I used AutoCAD and I shortened it a little bit. I reduced the width and the height. I gave it this cool little channel, so now the camera is actually captured.
You just slot it in there.
You just slot it in there, and there's a little hole at the bottom for me to get the wire out of the camera. And then the battery, oh, I just dropped my cap. And then the battery actually fits on the sled. Now, all this wiring is messy right now, but ultimately, there's going to be another piece that snaps over the top, and it will literally be a pod.
See, that's what I love about the idea of 3D printing, is that you can take something that someone else built and then modify it to your own needs. And what's the speed like on it, though?
Okay. Speed will depend on resolution. Like I said, you can print as small as 0.1 millimeter. Right? So that gives you really fine resolution. That gives you something like this.
Yeah.
So, very nice look to it. But that takes longer because it's got to make more and more layers of really, really small layers.
Makes sense, yeah.
Well, versus something like this. So this is printed very rough. I used 0.5 millimeter on this, and you can kind of see it.
It looks a little rough, yeah.
It's a little rough, but I didn't need something that was,
pretty.
So pretty.
It just needed to be solid.
Exactly. So it depends on what you choose. Something like this pod right here, this took me about an hour and a half to print.
That's not bad. Yeah. That's quicker than if you had to ship yourself a pod from,
like these,
quadcopter.
This takes like 10 minutes.
Yeah,
a set of 4, because they're tiny, right? And then you've got things like this. Does this look familiar at all?
That looks like one of the panels that would hold the camera.
Exactly. Remember, we made it out of Instamark, right?
Right.
Well, this one is like, oh, wait a minute. They actually have a template for this.
That one looks a lot nicer.
This looks a lot nicer, and it's a lot more sturdy.
It does, yeah.
And, the other nice thing about this is once you dial it in, you can always print.
That's cool.
You don't have to order parts. Like, I'm always breaking things. Well, I don't have to worry about that anymore.
Right.
I have a bag full of spares, and you're really only limited.
You can drop them with no fear.
Stuff. No fear. It's not going to break. No. You're really only limited by what you can imagine.
One of the biggest pains, though, is we got a 3D printer, I don't know, maybe a year ago, and you always had to calibrate it. And so I guess this one is all self-contained. So
that is one of the other things I really like. There is no calibration on this.
That's cool.
None whatsoever. You will never have to calibrate unless you break it. Like you physically jolt this thing.
So don't let Burke touch it.
Don't let Burke touch it, because then there are controls where you can set the offset, so you can have the head lower because the bed has changed. But as long as you don't mess with anything inside of here, you're never going to have to calibrate. Right? The only thing you have to worry about is running out of filament and the head. Sometimes you'll have to clean the head. Although I've only had to do it once, and I didn't really have to do it. I just wanted to see what the process was.
And what is the process? You just you take
yeah, you let it heat up, and then you basically, there's like a little fuzzy pipe cleaner, and you put it up into the head, and you tear out any debris that might have accumulated.
Okay.
Yeah. Speaking of that, there is one thing about the XYZ printers that some people are not going to like.
Yeah, you were telling me about this, and this feels a lot like a regular ink printer when you think about it.
I get what they're going with. So I don't want to open this because, oh, by the way, we're going to be talking about a lot of tips for 3D printing. One of the things is when you get filament, it's normally stored in a bag with a bunch of desiccant. Don't open it unless you're going to use it. Filament will, by nature, absorb humidity.
Really?
And if it absorbs humidity, it actually affects the way that it prints. So you only want to break it out of its bag when you're about ready to print.
So say you've hooked up a filament to your 3D printer and you wait like a few months to use it again.
So you want to take it out.
Replace your filament?
Yeah. Well, no, not replace it, but if you're gonna like let it sit for a while.
Yeah.
This is another thing I really like about this. It's one-touch load and unload. Loading and unloading a printer is normally a pain in the butt. It's not fun. This actually gives you an option. You hit unload, it will heat up the head, pull back the filament, and then you can just unload it, right?
That's
and then
cool.
you take it and you put it in an airtight bag with some desiccant, and it's good to store. But each of these spools has an NFC card. Now I know
I knew there was a catch.
people are going to cry foul. I know they're going to cry foul because it sounds like, oh, you've just DRM'd your filament. You can buy this filament cheaply on the interwebs, and this stuff's, it's about what, $22 per kilogram, per 2 kilograms.
Okay.
The XYZ stuff, which is, I mean, it's the same as the generic stuff,
but it's marked
like
up
20 to 40% more. You might think, oh, I could just load more filament on the spool, but unfortunately, in the spool right here and right here, there's an NFC card system, so that when you put a spool on, now here's the good part: it knows exactly what you've loaded.
Right.
It knows the temperature that it should be setting the extruder for. It knows how many meters of filament you have left, so it won't start a job if you don't have enough filament to complete it.
Right.
But it also means once that counter hits 0, it won't continue to print.
Right. So it's
Which, yeah, it's a sad trombone.
I mean, you did make some good points about why they would want to do this.
Yeah. I mean, I don't think this is. I get what they're doing. They're in trying to make a beginner's printer. They're trying to cut down on things like you can buy bad filament, and suddenly you're breaking the head because there's a bunch of debris. It's not really pure PLA.
When you start a project, the printer will know how much filament you have, so it can say you need to add more if you're going to do this project.
I mean, look, of course you can't see this, but Brian, you can see this. I can go right here. I can go to information, and it will tell me, if I go to spool stats, what I started with. So I had 100 meters to start off with. I got 26 meters left.
Yeah.
So it will tell me at the beginning, because the program that I use to create the STL, turn the STL files into EW files, it will say this will use approximately 6.2 meters.
Right.
And so I know in advance if I should load up a new spool.
I know. It just...
I know. And I will say this, and I love the guys at XYZ. Thank you very much for sending me this printer. I may have already hacked it. I know.
Well, yeah, we'll see what we can do.
We'll see what we can do about that.
There's a lot of places to get a filament.
Now, this was just a quick demonstration. We wanted to show you what we're going to be using over the next couple of weeks, because we're going to be bringing you a lot of 3D printer projects.
I'm excited about playing with that.
Next week, we're actually going to show you the first print. So once you get one of these, and you will be able to get it now, literally it was released less than 24 hours ago.
Very cool.
You'll be able to get one of these things, and we'll show you the entire process and the advanced process. Everything from how do you load it up, how do you prepare the bed so you can print on it, how do you get the print off, and then the week after that, we're actually going to show you how you can start modifying some of those STL files so you can customize your builds to what you want to see.
I know we were talking about this earlier, but I'm going to have to start dusting off my old AutoCAD skills to make some models.
Yeah, AutoCAD, and this will do STL, standard STL. It also does EW, which is the native format for XYZ, and they include a program that will convert STL into EW. You don't have to, but I like it because their software, even though it's very rudimentary, it will let you do things like flip it and turn it, rescale and such. It's good for people to start thinking about how a 3D printer has to print. It prints from the bottom up.
Right.
So if you've got like a structure where it's a single plane and then it breaks out, it's like, no, you got to flip that over.
Yeah.
Because that big breakout should be at the bottom. Print it upside down.
You have to start thinking in 3D printer dimensions, yeah. And you have to plan your the size of your project and decide if you have to like compartmentalize it.
Yeah. So folks, the future 3D printing. Speaking of the future, let's go ahead and take a moment to thank the sponsor for this episode of Know How. Now, Brian, we're talking about tools here, right? This is a tool.
This is definitely a tool.
But you know what? This ain't a fundamental tool. When we talk about fundamental tools, we talk about the tools that you're going to need for pretty much every project that you do, which is why we are always happy when we've got iFixit on the show. Now, iFixit isn't just tools. I mean, they make great tools, but what iFixit really is a place to go to find out how to fix things. They're not just a collection of drivers and spudgers. They are a one-stop shop for all of your know-how manuals. You want to figure out how you fix the red ring of death on an Xbox? You want to figure out how you fix clothes? You want to figure out how to fix that car that you've got? Well,
Fix McDonald's toys.
Fix McDonald's
toys. Old Game Boys.
Yeah. Now, Alex got some B-roll that he's going to run over the top that will show you the ins and outs of what the iFixit toolkit looks like. This is 70 tools to assist you with any mod, any malfunction, or any misfortune that may come your way. This toolkit is the gold standard for electronics work, from garage hackers to the CIA and the FBI. But more importantly, their unique tools are used by repair technicians everywhere, and they are the preferred tools of the know-it-alls. Now, this includes, as you see, a 54-bit driver kit with 54 standard specialty and security bits, Phillips bits, Pentalo bits, Torx and Torx security bits, tri-wing bits, triangle bits, those pesky ones that let you open up McDonald's tools. iFixit gives it to you all, including a swivel top precision driver and a flex extension. One of my personal favorites, this thing right here, which allows you to reach into those hard-to-reach areas with those crazy angles. It also gives you a set of ESD Safe Precision tweezers, anti-stat wrist wraps so that you can make sure you don't damage your electronics, nylon spudgers, metal spudgers, plastic opening tools so that you can open up your electronics without damaging them. It's only $64.95 and it's backed by a lifetime warranty. Look at our own, Alex, he's going to demonstrate that. Okay, you know what? It doesn't stretch that far, but yeah, good try. Now, hobbyists and home DIY fixers alike, use the ProTech Toolkit for doorknobs, for eyeglasses, for cabinet doors, sink fixtures, and more. If you're looking for a great addition to an artist or hobbyist tool chest, look no further. Best of all, there are thousands of free iFixit guides to help you put your tools to use. So here's what we want you to do. We want you to get fixing. We want you to fix your phone. We want you to use this cool mat. We want you to get the right tools for the right job. With iFixit, you can fix it yourself. Visit iFixit.com/twit for more than 10,000 free step-by-step guides. iFixit also sells every part and tool you'll need. Enter the code KNOWHOW at checkout and you'll save $10 off any purchase of $50 or more. That's iFixit.com/twit. iFixit.com/twit. And use the code KNOWHOW to save $10 off your purchase of $50 or more. And we thank iFixit for their support of Know How.
Yes, one of these lives at my desk downstairs.
You know, I think like 6 of them live at Burke's desk.
But yeah, well, I don't know if you'll be able to put any of them back together.
Burke,
keep your kits organized.
We may need an iFixit guide to fix the iFixit kits at Burke's desk.
Maybe that should be one of our know-hows, yeah. How
to repair your
iFixit kit.
Okay, folks, now we did want to move on to something that is near and dear to our heart. And that is taking electronics that you may already have and maybe breathing some life back into them. Brian, tell me what's in the box?
What's in the box? What is in this Heil sound box that I...
It's not a Heil sound. That's now a Cranky Hippo.
This is a Cranky Hippo box.
Yeah.
Well, you know, there was a few weeks back that the Nintendo released the new DS.
Right.
And I picked it up, and I've had a lot of fun playing it. A lot of great games that are on that platform. But it didn't scratch the kind of the nostalgia itch that I was hoping it would. And lo and behold, I was rooting around in my closet and I found my old Game Boy.
You'd never forget your first Game Boy.
No, it's got that iconic look to it. So if I open the box, hold on.
If you can open the box. Did you glue the box shut?
No. I'm imagining that there's gonna be like rays of light shining, emitting from it. Either that or like Indiana Jones, where everybody's faces get melted off. But yeah, pulled out the old Game Boy.
Okay, it's not like original, because all the originals were plain vanilla white.
Not so, sir.
This is a color one.
It's a colored case, but that one was released, back in 1990 or 1993. Nice. The very early ones, like the first release, yes, where they were gray and they had the different buttons and stuff, and that is actually the one that I fixed in the video. You have one of the legit ones?
Seriously, my serial number is like in the low thousands.
Yeah, okay, I believe it. You should bring it in sometime.
No.
You afraid that I'll break it?
Yeah, no, not you.
Well, anyway.
Someone near the no-hole, maybe.
The whole reason I busted this out, but I wanted to play some of the old games. I've got Pokemon Gold in here right now. But
I had Pokemon Gold, but it was yellow.
That's not Pokemon Gold then.
No.
That was yellow.
So
you have the one Pikachu follows you around.
Oh man.
But anyway, this was first released in 1989. I don't think I picked it up until a few years later. I was only 4 years old at that time. But one of the common things that happens with these poor guys is that they get these vertical lines on the screen.
I had that happen. Now, on mine, I could hit it a couple of times and
they
it would
come
go
back
away.
That
doesn't always work.
So the fun thing about working on some of these old electronics is that they're really easy to take apart as long as you have. I mean, the iFixit kit helped a lot because you have tri-wing screws on the back. But then once you're in there, all the components are kind of spaced out. It's not like when I've done a teardown on a new cell phone or something like that.
No, everything is they're all in one IC.
This was like meant to be taken apart by human hands, and you can actually get in there and do some stuff. And now that I'm almost 30, this thing is 20-something years old now too. There's been kind of a resurgence of people modding these and stuff, but to fix the screen lines was super easy, and too many of these have been tossed in the garbage because people think they're broken. When in this next video that I made, you can fix this within like 10 minutes and it'll be back to brand new.
Well, there you have it. Hey, Alex, why don't we see how Hippo fixes a screen?
So this little brick of nostalgia is the original Game Boy. If you're not familiar with it, well, you should be. This is the predecessor to all the mobile games that you enjoy now, and it was released way back in July 1989. In the first day, it sold over 40,000 units, and we're going to breathe some new life into this old Game Boy. The nice thing about the Game Boy is that it's really easy to disassemble if you have the right tools. They have tri-wing screws in the back of the Game Boy, and as long as you have an iFixit case or a tri-wing screwdriver, you'll be able to get these out in a jiffy. There are 6 of them, 4 on the back, and then 2 behind the batteries. Once you've got those screws out, you can flip the back of the Game Boy around, and you've got yourself a pretty easy access to the board compared to like modern electronics. This was built in the day that you could actually work on it. The problem with this Game Boy was that it had vertical lines missing on the screen, which some people might think was a death sentence for these little guys once the screen starts to die, but it's really easy to fix. So we'll take out all the Phillips screw heads that attach the front board to the front of the case and just pop those out real quick and flip the front board around so you have access to the screen. Because what we're going to need to do now is heat up our soldering iron, and there's this black piece of tape that runs along the front of the screen here. That is where the soldering is attached to the LCD screen. And by just heating up your soldering iron and running it over that tape, which is very heat resistant, so don't worry too much, you can reflow the solder and have the LCD screen come back on and retrieve those missing bars. So just take your time. I would recommend leaving the screen plugged in so you can watch what you're doing. Heat up your soldering iron and leave it on the edge for no more than 3 to 5 seconds and watch as the LCD screen starts to come back to life. Just work your way up and down the length of the board, and eventually, if you take your time, you'll have brought back all the little remnants of the LCD screen and bringing this Game Boy back to working order, which is awesome and super easy. This took me about 15 minutes to complete. Also, there's a little black piece of rubber that you have to pull off to get access to the solder where you're going to be putting the soldering iron. Make sure to hang on to that and put it back on, and maybe put a little tape to hold it there or some glue or something. This is going to help protect those soldering joints that you just reflowed by giving it a little bit of cushion against the case. Not only did you have a little fun and learn a little bit about this old piece of tech, but you brought it back to life, and it definitely scratched that nostalgic itch that I had, and put everything back in the reverse order that we took it apart and put back on the front screen, and you've got yourself a fully functioning piece of hardware from 1989, 25 years old. But we're not done. We're going to keep adding stuff to this Game Boy in later episodes, so stick around.
And so now that you've done your screen fix with the vertical lines, there was I wasn't stopped there. I didn't want to end there.
See, this is a good geek, because you're just never happy enough. As long as I'm in here, what else can I fix?
I wanted to add.
Oh, wait, what?
Yeah. There's these
That's
really
possible?
really easy cheap kits that you can get to and backlight this, because these are nearly impossible to see unless you're in broad daylight or have like
I had an attachment that went into the little game port here,
and then
it was like an LED light over the top.
Yeah, really kind of janky.
It was janky, but it worked. But yeah, backlight much better.
Yeah, so it's not too difficult to do. The kit's pretty cheap, and I think next week I'll show you guys how to do that. A little bit of soldering, but if you've done any soldering, or you did the project that I did 2 episodes ago with the
watch.
The watch, this is not difficult at all.
Yeah, as long as you're going to be poking around your Game Boy, why not
make it better?
Improve it.
Yeah. So having a lot of fun playing with that.
Yeah. Nice. Now, speaking of improving things, we know that we've gone a little quadcopter crazy, so we wanted to back off a little bit and give you a different kind of quadcopter knowledge thing. Now, it's still very much quadcopter technology, but we wanted to show you how we choose motors here on Know How. Alex, if you go to the overhead shot, this is a thrust bench. So I just got this from Hobby King. It's a standard thrust bench measuring stand. All you need is the bench itself. You need some blocks to hold it down. Actually, this is not enough. If I crank this thing up to full, it will start to move away. But the idea is you need a way to be able to measure how much thrust a motor and prop will develop. And the reason why this is important, we talked about this, Brian, because that will vary depending on the motor you use, the prop, the angle of the prop, the type of battery that you use, even the ESC. So this is the scientific way to choose what parts you want in your quadcopter.
Would this be a good way of diagnosing if you think one of your motors is failing?
Actually, yes. Yeah, you can put all 4 of your motors on a bench, and you can figure out, oh wow, this one only has half the output as the others. It's somehow damaged. Because when it's in the air, you can't.
It's really hard to tell.
Yeah, it's a
you just
single
can tell
unit.
that it's not flying well.
Right. I would consider this an essential piece of technology. It's something that you need in your toolkit if you're going to be doing some serious aircraft building. I'm not even saying quadcopters, because this will work for anything that you have to test the thrust of. In fact, I've been able to use this for airplanes that have been flying around.
This is cool. How much is this little kit?
It's like $50. It's not. You can make it a lot cheaper. In fact, we're going to be showing you in a future episode how you can make an inexpensive one for about $10.
It feels really solid, though.
But this one is solid. Yeah, that's what, because I made a janky one. I'm like, I want to see what a real one looks like. And now that I have the real one, I'm not going back to the janky one.
Okay.
Now, let's talk a little bit about those questions about the motor and the prop. Like, for example, we've got 2 different motors here. This is one of the Emax, the 2213s that I've recommended for Project Alien X. I kind of favor these. Very durable, not that expensive. I mean, you can get them as low as $14 a pop if you buy them in 4. Versus this is a Hobby King motor here that I have got on this thrust bench right now. It's technically rated the same, but we're going to see in a bit that it's not.
Not the same.
It's not the same, yeah. And really
so when you look at the specifications on the page, it says the same numbers and everything?
It says the same numbers, and that's the problem. Those numbers are, I mean, they could be total lies.
Misleading.
Yeah. And I can tell you right now, just the operation of this, safety.
Yes, safety first.
We got safety next week. The operation of this is not nearly as nice. You hear a little bit of a rattle.
Yeah.
You don't get that on this, and it's just like it's the quality of the bearings. And
how much was this motor?
Like that's $10.
$10.
Yeah.
So,
but $10 versus $14, it's like pay the extra $4 and get yourself something quality.
Okay.
Now, we want to look at the size of the motor. we want to look at the size of the prop, and we want to look at the rating. So not just 3-cell, 4-cell, but the rating of the battery. How fast can it supply power through the ESC to the motor? Because those will all affect how much thrust I can generate for any particular prop motor combo. Remember, we always talk about the combo.
Yeah.
Because you can buy a really good motor and put a bad prop on it. You can get a great prop and put a bad motor on it, and it's just not going to work right.
Or buy a great prop, a great motor, and have a crummy ESC.
Yeah, exactly. Now let's start with choosing your motors. We've talked about this before, but it's worth repeating. When you choose your motors, remember that you've got typically 2 numbers. There's a rating like 2213, and so like a 2213 is a bigger, more powerful motor than a 2208.
Okay.
Right, and that just refers to like how many winds you got in the inside. I don't want to give you an exact definition because it actually changes from manufacturer to manufacturer. But on a whole, the bigger that number, the more power it will be able to output.
Okay, that
the
makes
more
sense.
power it can take in. The more important number is the one next to it. Like this is a 2213 1100 kV. And remember, we know from kV that kV is the number of times that this thing will spin, one number of revolutions per volt that I give it.
Okay.
So this is an 1100 kV motor, which means if I give it 10 volts, it's gonna spin 11,000 times a minute.
Yes.
Okay, so that's my rotation.
Okay.
Now we also remember from the way back when, motors that spin faster typically offer you less torque. Motors that spin more slowly offer you more torque.
Which is better for bigger props.
Right, exactly. So if I have a motor that spins at 2300 kV, but it's rated 2213, it means that it needs to use a smaller prop. It's just going to spin it more quickly.
Right.
Something like this, which is 1100, and they've got motors that spin at like 600 or 680 kV. Those are designed for the huge props, which theoretically, actually not even theoretically, practically is more efficient. When I spin my prop more slowly, a bigger prop more slowly, I will get more flight time out of it because I'm not spinning it so fast, which is kind of wasteful.
Right, but then that's would be less of a performance or aerobatic kind of quad.
So when I'm building like my 250 class, I use the 2300 kV motors because I want that motor to be able to spin up and down really fast because that's what gives me all the crazy acrobatics.
Right.
But like if I'm building my this is why we chose this motor for the 450 class. If I'm shooting, I want to use a big prop because it's going to spin more slowly, less vibrations. It's going to be more stable, and it's going to give me more flight time. Because I'm not going for acrobatics.
You're going for film quality.
Going for film quality and time in the air.
Yeah.
Okay, so
cool.
Now we know that. So that's choosing our motors. Next is choosing the props, and we've kind of led into this. We've talked about this before. This is a nylon prop.
Yep.
And you can see it. It's like flexing. So you hold on to that. This is a carbon fiber. There ain't no boing in this.
Stiffness.
This is stiff. Now, okay, people will debate this. You have to balance all props. It doesn't matter if it's nylon or carbon fiber. You do have to balance them so that you don't get vibration.
Yeah.
Carbon fiber props tend to be lighter. Lighter props will spin up and down more quickly, and spinning up and down more quickly gives you more acrobatic.
Which would then make them also more efficient because there's less work for the motor to spin up and down?
Yeah, it does.
Marginally.
But some people like the nylon because they will flex, and to a certain extent, props that flex will take some of the vibrations that would otherwise be transferred into the frame. It doesn't always work that way. In fact, I found I just run carbon fiber all the time.
Yeah.
Unless it's a trainer craft, and I'm worried about, because if you snap carbon fiber, if you hit something with carbon fiber, it will
cut you.
It will cut you. Nylon, this actually will not cut me. This will mark me, but it won't cut me. This will first it will snap off, and then it will leave a jagged edge, which will cut through my skin.
Yeah.
Not good. No bueno. No bueno. But if you'll notice, this is a 10-inch prop. This is an 8-inch prop.
And then
that's a 10-inch prop.
Ah, okay.
Yeah.
So.
And I think this is a 10-inch prop as well. You can have multiple types of 10-inch props. So if the angle on this, you can't really see. Look through the overhead, Alex. Let's see if it, not really, doesn't really show off. But the angle is slightly different. This is a more aggressive prop. It has a higher angle, which means it's gonna pull forward more in one revolution.
Generate more thrust.
Yes, but it also means that it will pull more power from the motor and, et cetera, et cetera.
Right.
Sometimes you just like a slow fly, because a slow fly prop will give you, again, that nice, smooth, long-lasting flight.
Yeah, the angle, it's the angle of the pitch on it?
Right.
Okay.
So increasing the size of the prop increases the amount of power that it will draw, but it also means you can run the motor more slowly. The practical use on the 450s that we just built, the Alien 450s, those motors can be used for both 3S and 4S batteries. That's the 11.1 volt or the 14.8 volt batteries.
Right.
Now, if you're going to use it with a 14.8 volt battery, you would go from these 10-inch props down to an 8-inch prop, because if you try to put a 10-inch prop on a motor that's supplied by a 14.8 volt battery, it will burn out the motor.
Okay. Yeah, because it's just so much.
It's demanding so much of the motor. It's just too much wattage. It will burn it out. Which that's the relation. So I can get a big motor, a big prop spinning slowly, or I can get a small prop spinning very quickly. And the nice thing about that is I change depending on how I want to fly it. If I want to get daring, like I did a montage last week of like my quad flying over the water. I used 8-inch props because I wanted the ability to punch out. If I was getting too close, I didn't want to have to wait for my props to spool up. I wanted to say, nope, throttle it up, get it out of there. But if I'm doing like the shot I did at the beach in Hawaii with that super smooth shot, those were 10-inch props because I knew I was just going to pan slowly. And I really didn't need a whole lot of performance.
Okay. And so now testing these on the bench.
Let's go to the fun part.
That's what I want to do.
All right, so this is a very basic thrust tester. All it's got is it's got a way to mount the motor. It's got a scale. So this scale, which is right here, will allow me to figure out how hard this thing is pulling and actually get everything away from this because it's going to get noisy in just a bit here. Sorry about this, Alex. I'm using a 3S battery. So this is 11.1 volts, and I think it's actually kind of run down because Burke was
playing with it.
Yeah, we was using it as an air conditioner.
This isn't gonna blow those props off the table.
No. So what I do is I've got a servo tester here, and I'm going to go ahead and slowly. You're gonna have to kill my mic. There we go.
Padre!
Sorry.
Okay, is there dust everywhere?
Really should clean the set
Did
more.
you keep track of the number?
I did. So this went up to 809 grams. So at its maximum, this motor with that prop and this battery will pull 809 grams of thrust.
Okay.
Now I got 4 of them, so I can get 3.2 kilograms worth of thrust out of my motors, which is a decent payload.
Yeah.
Especially since the frame is only going to be 300 grams, 400 grams.
Yeah, it's
max
a good power
everything.
to weight ratio.
It's a good power to weight ratio. Now let's go ahead and take a look at a motor that has the same rating as this. It's our wonderful little Emax 2213.
Man, I didn't know you could move that fast. You changed that motor quick.
That's right. Take a look. That's that instant quick movement that we learn in the Jesuits. It's a priest.
Fast hands.
Fast hands. So what we've done is we've gone ahead and replaced this Hobby King multi-star motor, which has the same rating as this, with this Emax 2213. Now we should note that we're using the same ESC.
Right.
And this is not my personal favorite ESC. Actually, this probably robs you of maybe 5% of thrust, but we want to use it as a baseline because remember, you want this is scientific.
That way we can compare the two motors.
Precisely. Right? So I've got this set up rotating the proper way. Now, one thing you should know, hopefully you know this already because we've repeated it several times in our builds. If you ever have a motor that's spinning the wrong way, all you have to do is reverse 2 of the leads. Just any 2, just flop them around, and it will spin the right way.
Right.
Okay. So now we've got the same setup. This is actually the same battery. In fact, we're at a disadvantage because we've already been draining this battery, testing the other motor. Yeah. What I have at home is I actually have a bigger battery that can withstand drain. It's much better. But let's go ahead and turn this on. Let's tear it out so we know it's at 0 grams. And we know the other one, at its max, was able to pull 809 grams of thrust. This is the exact same rating, the exact same speed, with the exact same prop. Let's see if it does any better. So
stand back.
Turn off my mic.
More power. Oh no. It's all over the place.
So actually, at its peak, this actually pulled 830 grams of thrust.
Yeah.
and it leveled off around 790 versus the other motor, which pulled at its peak 809 grams of thrust, and then it leveled off somewhere like 760, 770.
Okay.
Right. And you're going to see that because whenever you see that pushback, it actually means the battery can't supply enough power to the motor. Yeah,
okay.
which we will address because next week, I'm actually going to show you a super advanced build. So this is a decent thrust tester, but it only gives you one metric. It gives you how much thrust am I generating.
Yeah.
The better kind of thrust tester will also show you how much thrust are you generating, how much power are you using, how much wattage and where it's being used in the curve. And it will also tell you whether or not you're starting to exceed the power limits of any part of your system.
Yeah, that does sound like a lot more information.
And believe it or not, you can do it with just $20 in parts.
Really?
Yeah, it's not bad at all.
Cool. Yeah, I'm looking forward to checking that out.
I got to tell you, I like flying quadcopters, but there's a part of me that it really squeezed to build stuff. I love building things, and this is a big old building toy.
That's how I feel about the Game Boy, and that's why I liked playing with Legos back in the day. It was putting it together that was fun, and then you get to have fun when it's built, but it wasn't the main part.
Yeah. Now, folks, we know that this was a lot of material for you to handle, and which why we're going to give you detailed show notes. So don't worry about that. Now, typically, this is where we go, right? This is where we would drop off after telling them that they could find our show notes where?
At twit.tv/KH, and not just show notes, but all our previous episodes and ways to subscribe and download the episodes.
Yeah. Speaking of ways to download the episodes, there is no better way than participating in the Google Plus group.
Yes.
And that's really the best way. Seriously, 8,300 plus folks, very active group. There's always someone in there who's posting. If you have a question, if you have an answer, if you're one of these people who you want to contribute your knowledge to the group of DIYers and makers, it's a great place to join. Just go to Google Plus and look for the Know-How group. Join in and ask a question. And more likely than not, if you've got a project that you want to post that you think is fantastic, we'll use it on the show.
And my favorite part is seeing other people's projects. There's been plenty of crash videos from the quadcopter people.
Keep sending those in.
There have been plenty of mods for some of the other things that we've done. So there's a lot of cool stuff to check out in there.
Yeah, and it's also a really good place for us to get ideas for future shows. So like, people wanted to see Raspberry Pi, so last week we did Raspberry Pi OSMC, and we're going to keep doing that. So suggest, ask, we'll answer.
Yep.
Yeah. Don't forget that you can also find us on the other social medias, specifically the Twitters. Just go to twitter.com/PadreSA. That's me. And then you.
And then me.
And then you.
I'm just so used to you saying at Padre SJ.
At Padre SJ.
And I am at cranky_hippo.
Yeah, yeah. One last thing before we go, we do this thing every once in a while that we call a parting shot.
Yes.
And there's actually a special one. There's something that no, Alex.
Okay.
Bad Alex.
Come on.
Bad Alex.
We're a little early. We got time.
We got time. Okay,
we got time. Let's do
because I need to do this thing because this thing has the SDO. This is the Solar Dynamics Observatory. This is a space project that I have just been geeking out over, and I've been containing my geek. Have you heard me talk about SDO?
No.
Exactly. Right.
No, you've done a good job.
I keep it to myself.
You have a very hard time containing your excitement about things.
Yeah.
So I'm surprised I haven't heard anything about this.
But this thing is beautiful. We launched it 5 years ago. It's been orbiting the sun. It's been taking high resolution images and videos once every second, and it's been absolutely gorgeous. You know, I don't want to talk anymore. Alex, just play this with the music.
Oh. Isn't that how you go back in time?
You have to go faster than that.
You go around the sun. I remember that one.
It's just gorgeous.
That is super cool. And any of those loops, so you could fit like...
Those are larger than the Earth.
Yeah.
I mean, you could fit like 1,000 of those.
Oh, yeah, easily. So pretty. Oh.
Now, the amazing thing about that is you're actually seeing the electromagnetic bands. That plasma is traveling along the electromagnetic bands that form on the sun. So it gives visual representation of something you otherwise wouldn't be able to see.
That is so cool.
It's beautiful.
And just the immense amount of gravity from something that huge.
Oh, the amount of power that you need to blow out that much material from a giant ball of plasma. I just wanna.
I just want to curl up next to it.
I've watched this video maybe like 100 times in the last month.
I want an apartment next to the sun.
Well, you need a really good air conditioner.
Yeah.
And sunscreen. I mean, you got burnt standing on a Segway. Oh, look at that. Seriously, right?
That's so cool.
So yeah, so what you're seeing is the reason why sunspots happen is because there's regular magnetic lines that flow through the sun, just like you get through the Earth, right?
Right.
But the surface is so turbulent, and the inner workings of the sun are so turbulent that the lines actually start to wobble, and then they cross. And when they cross, you get like a short circuiting, and it causes that expulsion of material from the sun.
That's crazy. Now, if you wanted to stop the reaction of the sun, we were talking about that. If you shot a giant ball of iron into the sun?
All you need is iron, because iron actually kills fusion reactions. You can't fuse iron. The sun is based around fusing lighter elements into heavier elements, but when it gets to iron, it stops. So you have all this pressure that just keeps pushing and pushing and pushing on the iron, but it won't fuse. And the sun, and actually any star, is actually a balance. It's a balance between wanting to explode from the reaction and the immense pressure and gravity pulling back in. So if you start to compress iron, which will not fuse and therefore will not create a plume of energy,
right,
it no longer has that thing pulling it back in, and now the star just blows itself apart.
I could watch this all day, Project.
I know, right? Okay, we got to come back. We got to come back. I'm sorry, I was just...
Oh, man. So cool.
That's it. I'm Father Robert Ballos here.
I'm Brian Burnett.
And now that you know how...
Go do it.
I'm going to watch the sun again.
I can't look away.
I'm like a moth.
Oops. No, it's broken.
Twit down. Put that in Jeff's face.
Never work again.